In this lecture, I'm going to introduce you to what statistics are, their common uses and misuses. So, according to the Merriam-Webster dictionary, statistics are a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. Well, this is strictly a bit inaccurate because we can even work with categorical or qualitative data, but that is something we will deal with later on in this course. So the numerical data or the data in question are a sample or samples rather taken from a population of interest with the view of deriving inferences about the bespoke population. Usually, collecting data about an entire population census is not possible, so representative samples are taken and inferences are drawn from them, and they are regarded to be applicable to the entire population. So, the population, the statistical population in question might be population of a country, and different samples of voters may be taken to estimate voting intentions. The polling companies that publish voting intentions and things like that, they are very common in most countries where we have democratically held elections, and essentially it is not possible to go to the entire population and ask them what their preferences are. So the next best thing they do is to either by telephone or by email they collect what they think are representative samples of the entire population, ask them about their voting intentions, carry out mathematical analyses on these, and then 10 days before an election you might find that such and such candidate is poised to win. So here are some bits about using statistics, and the upshot is that while statistics are used in a variety of different fields, political forecasting, medicine, ecology, samples used in all these cases are usually drawn as a representative of the entire population. So we don't use the entire population and we use the sample or samples to draw inferences. So here we have a very recent newspaper article published on Saturday, April 2017, and it says that Conservative Party in the United Kingdom is on course for landslide victory in elections, poll suggests. So Observer and Opinium, they carried out a survey, and in that survey they spoke to people of the United Kingdom, or a sample that they believed represented the population of United Kingdom in terms of demographics, socio-economic and ethnic breakups, and based on that they are predicting that the Tory party or the Conservatives will get a landslide victory in the forthcoming general elections. That is something we will know on the 9th of June 2017. Another survey was carried out, and it shows that 1 in 7 Labour voters, they have turned Tory. So again, this particular newspaper that commissioned a poll, samples were collected, analyzed, and on basis of that an inference has been drawn that out of the entire population of Labour voters in United Kingdom, 1 out of 7 are going to vote for Tories or the Conservative Party. There are other areas that also use statistics. So this is a medical article and it asks if food allergies are on the rise, and in order to answer this question they selected what they believed was a representative sample of the population of United States of America, asked them about their food allergies, etc., and came to the conclusion that food allergies are on the rise. In this case, this pertains to ecology, and in a given study area in Asia, they went to different habitats. They went to an eco-forest, a degraded area, secondary growth, and they just observed the number of species, and now they produced a chart telling us about the different about the number of species, avian species present in the different forests of that area. Obviously, it is not possible to examine every forest in Asia or every forest in a given territory. So they believe that all of these areas, forests, they represent their landscape, and these are the number of species they believe they contain based on this particular sample. So this is how we use statistics, and we use it for academic studies like studies in ecology or medicine, or even when you open the newspaper, there's no getting past statistics. Now, while it's a valuable tool, this tool is also very easily and often misused, accidentally or deliberately. So now I'm going to talk a bit about the misuse of statistics or statistical disasters. 52%, this particular figure, apart from representing the biggest upheaval post-war Europe faced, is also a classical example of a statistical disaster. In lead up to United Kingdom's referendum to leave the European Union, also known as Brexit, many surveys were done about voting intentions, and data was statistically analyzed. So different samples of voters were contacted. I was not. And they were asked about their voting intentions, and after the data analysis was done, on June 22nd, one day, or well, less than 12 hours before the referendum opened for polling, this ComRes poll showed a significant lead for Remain. 30 minutes before the polling closed on June 23, 2016, UK was expected to remain. When we woke up on June 24, people wanting to leave the European Union, they got 52% of the votes as compared to Remain's 48% votes. And this was the BBC headline, Europe stunned by UK leave vote. And I'm not surprised, because if 2 days before you read something of this sort, that UK was expected to remain, and first thing in the morning, 24th of June, you read that UK has decided to leave. Yes, it was a stunning news, to say in the least. But just one more thing about this 52%, it does not represent 52% of UK's population, and this is a very common way in which we end up misinterpreting or misusing statistics. That, so many people, they say colloquially 52% of UK's population has voted to leave. No, it is 52% of the people who actually voted, either in person or by post, and there were eligibility criteria for who could vote. You had to be over the age of 18, you had to be either a citizen of United Kingdom or a Commonwealth citizen. EU residents and citizens were not allowed to vote. So out of the eligible people, 52% of the people, they voted for Brexit, and that is not 52% of United Kingdom's 60 million plus population. Now, the reasons for such statistical disasters are either poorly collected or biased data or wrong statistical tests. Now, the statistical tests in this case were accurate because these firms, they're multi-million dollar or multi-million pound polling and survey firms, but in this case they ended up collecting biased data, and which led to a major embarrassment for almost all the major polling firms in the United Kingdom. So our course is not going to focus on political polling and things like that, and most of the course will be devoted to learning about the different statistical tests that there are, how to implement them in R, and which test to implement when. That is also a very important thing to know. In the next lecture, I'm going to tell you more about designing studies and collecting appropriate data so that you don't end up with a biased sample and an egg on your face like all these polling companies ended up with.